Hi everyone, today we will expand on the concepts from the pre-class video on Brightspace. For that, we will use Matlab to analyze engineering data. So first, we are going to work on an engineering scenario to find the question we want to answer, and then we will translate it into a Matlab condition. To do that, we use relational operators and logical indexing. And throughout this process, we will interpret Matlab output according to our engineering context. So let's stick with the same engineering scenario from the pre-class video, where an engineering team is monitoring the temperature of a battery during testing. Here's the question we are starting with. Is the battery getting too hot? That sounds like a reasonable engineering question, right? But before we jump into MATLAB, let's think about whether we can actually answer that question yet. Can we answer it as it is? Or what information are we missing here? So we know we are monitoring the battery temperature, but we still need some additional information. For example, we need the actual measurements, and we also need to clarify what mean by too hot. So in other words, we need a criterion that will help us decide which temperature to require our attention. For this test, let's define our criterion this way. Temperatures above 50 degrees Celsius require further investigation. So I want you to understand that this is a common part of engineering work. Problems do not always arrive perfectly defined. Sometimes the first step is not writing code, right? The first step is clarifying what the question really means. Now that we have a criterion, let's see the computational question. At which measurement times does temperature exceed 50 degrees Celsius? Well, there's a question MATLAB can actually help us answer. But before jumping to code, let's identify the data we need. So let's ask ourselves what we know about the test. We know the battery was tested for 60 minutes and temperature was measured every 10 minutes. So before we write code, let's describe those measurement times in plain language, okay? So ask yourself how you would describe the measurement times without using MATLAB syntax. You can write in a piece of paper or type on your computer if that helps you to think through. And I will give you a few seconds thinking about it before we move forward. Good. In plain language, our measurement times starts at 0, step by 10, and end at 60. So we know the step size, right? Measurements happen every 10 minutes. Now, based on the previous lesson, would the column operator or linspace be a natural choice here, and why? Let's think about it. Well, if you remember about our pre-class video, your answer is probably the column operator would be the most natural choice in this case. It's not that linspace is a wrong choice, but the column operator would be useful in this situation. But why? Because we know the interval between measurements, which is every 10 minutes, right? So column operator is a good fit. Like this is exactly the kind of situation where the column operator would be useful. And the reason is not just that we remember a command. The reason is that our problem gives us a start value, a step size, and a value, an end value. All this to say that in MATLAB that becomes time equals 0, colon 10, colon 60. This means you start at 0, move in steps of 10, and continue through 60. Well, so let's take that idea into MATLAB and see what it looks like. So we are going to type time equal 0, 10, 60. And here's the output. So here we have the time interval, meaning the temperature of the battery will be measured starting at 0 and then after 10 minutes, 20 minutes, 30 minutes, and so on. So now that we have created the time vector, next we will create the temperature vector. So let's say the engineering team measured the temperature of the battery each 10 minutes as defined the time in the time vector. Here's the data collected: 25, 28, 32, 38, 46, 55, and 63. So at this point, we have two vectors, one for time and one for temperature. Well, let's pause here for a second because I think this connection really matters. What relationship do you notice between these two vectors? Think about it. What could be the possible relationship between them? Like maybe they have the same length, right? 7 times they appear here. And they have the same number of values, and each temperature corresponds to one time. Look at the first value in each vector. The temperature 25 measured at 0 minutes, 28 at 10, 32 at 20, and so on. So the positions line up, right? So in Matlab, let's type temperature equal, don't forget the brackets, 25, 28, 32, 38, because it's the data we collected. 46, we just copy the data here. 63, bracket. And boom, exactly how we have here, right? So far, we have the data, but right now we are just looking at numbers. So a graph can help us see the overall pattern before we ask MATLAB for a precise answer. But before we create this graph in MATLAB, let's think through it. So what relationship are we visualizing? The relationship between time and temperature, right? So we have two variables, time and temperature. And when we think about displaying this relationship in a graph, we can ask which variable should go on the horizontal axis and which one should go on the vertical axis. So the answer is simple. Since the time is how the test progresses, we will put time on the horizontal axis. And temperature is what we measured, right? So we will put it on the vertical axis. So in MATLAB, we will plot temperature as a function of time. And how we do that? We do that by typing plot time temperature. And here's just the style that we want the graph to display, the line. And here's the graph that was created. You see, like at 0 minutes, 25 degrees Celsius. At 10 minutes, the battery was tested again, and now it's 28 degrees Celsius. And as you might remember, our question is if the battery is getting too hot, and it shouldn't cross 50 degrees Celsius. So far, so good. So when the battery reaches the 30 minutes, it's 38 degrees Celsius, 40 minutes. Again, it's 46 minutes, 46 the temperature. And here, when it reaches exactly 50 minutes, it is above the 50 degrees Celsius, right? It's 55 already. And 60 minutes after 1 hour, it reached finally 63 degrees Celsius. All right, so here is some code to create the graph on your own and add some labels, just to make it more readable. And now let's remember our criteria. Temperatures above 50 degrees Celsius require further investigation. Before we write the MATLAB condition, let's first express what we want MATLAB to do in plain language. We have several temperature measurements, right? So for each temperature, we want to ask the same yes or no question. What we want to know is is if the temperature is greater than 50. So for a temperature of 25 degrees, the question is 25 greater than 50? For 28, is 28 greater than 50? And so on. And MATLAB can ask that same question about every value in our temperature vector. Now we can translate our plain language question to MATLAB. Is this temperature greater than 50? Becomes temperature greater than 50. We know that his greater, the greater than symbol is a relational operator. So MATLAB will compare each element of the temperature vector with 50. Well, before we see the result, what do you think MATLAB will return? Let's think about it. If you do this just by thinking about it or maybe writing down, like the question is this temperature greater than 50? Yes or no? Yes or no? Yes or no? So let's see how it looks like. So because MATLAB is asking a yes or no question about each element, we should expect one yes or no result for each temperature measurement. In MATLAB, these results are represented as logical values, false or true. So is this temperature greater than 50? No, so it's false. Is 28 greater than 50? No, false. And then when it finally reaches here, it's true, becomes true and true. And here's what we expect. MATLAB compares each temperature with 50 element by element, as I said, I just said that. So looking at this logical array, what can we conclude here? That only the last two temperature measurements exceed 50 degrees Celsius, right? So let's go to MATLAB again, and let's see, temperature greater than 50. And what it's gonna show us? It's gonna show us which temperature is greater than 50. And here it displays a logical array, and it's exactly how we did before. So it checks each point, and when it becomes greater than 50, it displays 1 because 0 is for false and 1 is for true. All right. Now let's go back to our original question. We are not just asking whether the battery exceeded 50 degrees. We are asking when it happened. In other words, at what measurement times. The logical array tells us which positions meet the condition. So let's think about how this true or false pattern could help us identify the corresponding times. Because each temperature and its measurement time are in the same position in the respective vectors, we can use the true positions of the logical array to select the correct values. Here, the true values are in the 60th and 7th position, right? So we need the 60th and 7th values from the time vector here, which are 50 and 60 minutes. So in plain language, all we just did was to say, give me the time values where the temperature is above 50, which is the limit. So here's the bridge between the engineering question and the MATLAB syntax. First, we save the condition above underscore limit equal temperature greater than 50. The semicolon suppresses the output, let's remember that, but MATLAB still stores the logical array in the variable above underscore limit. Then we use the logical array as an index for the time vector. Time underscore above underscore time equal time above underscore limit. And basically this means return the time values in the positions where above underscore time is true. Let's test this in Matlab. Above the score limit, equal temperature greater than 50, then time above limit equal time above limit. Yes, so MATLAB gave us the correct answer, which is time points 50 and 60, which is here. You see 50 and 60, which is true. How would you communicate this result to your engineering team? Remember, the important point is not just the numbers, right? In context, this means that the battery temperature exceeded our 50 degrees Celsius criterion at the measurements taken at 50 and 60 minutes. Now imagine the engineering team changes their requirement. This happens all the time. The data may stay the same, but the questions change. The new requirement is identify temperatures at or above 45 degrees Celsius. Do we need to start the analysis from scratch? That's the question. We don't need to start over, right? Because our data and our overall strategy are still useful. The time vector stays the same and the temperature vector stays the same. The logical indexing strategy also stays the same. Now the question is what needs to change? Simply the condition changes from temperature greater than 50 to temperature greater or equal 45. That's all that we need to change there. And here's the original condition, temperature greater than 50, that becomes, wait a minute. Yeah, here is the structure of the condition. This stays exactly the same, but the criteria changes. And now the condition becomes temperature greater or equal to 45. Now let's go to MATLAB and see the new results. Let's run updated underscore limit equal temperature greater or equal 45 semicolon time updated underscore limit and temperature update limit. Updated limit. So here we have, look what we have, 46, 55, 63. It recognizes the data points. So let's step back from the MATLAB syntax for a moment. The code we used today was not very long, but the bigger goal was learning how to move from an engineering question to a computational answer. We started by clarifying a question that was too vague to answer directly. Is the battery getting too hot? We defined what too hot meant for this test. Then we identified the data we had, measurement times and temperature values. We also paid attention to how the position in the two vectors corresponded to one another. And next, we visualized the pattern so we could see the overall trend before computing a precise answer. Then we translated the criterion into a MATLAB condition, temperature greater than 50. And that condition gave us a logical array of true and false values. Then we used the logical indexing to interpret the output in context. The output was not just 50 and 60, it meant that the battery exceeded the temperature criterion at the measurements taken at 50 and 60 minutes. And when the requirement changed, we did not start over, right? We asked what stayed the same and what needed to change. So in this test, our computational answer was that the battery temperature exceeded 50 degrees Celsius at the measurements taken at 50 and 60 minutes. And more importantly, we practiced using Matlab as a tool for engineering reasoning, not just as a set of commands to memorize. I would be happy to discuss the lesson design, the Matlab content, or how I would adapt this for different first-year engineering students during Q&A. Thank you very much.